Jai Hind everyone. Today in the continuation of lecture series of software engineering. So in the previous lecture we have discussed some introduction part of software engineering. So introduction to software engineering, then the software components, software characteristics, and we have discussed about some software failures, software crisis. So today we will discuss in detail about what is the software engineering process, or what are the similarities and differences from conventional engineering processes. Okay. So we have already discussed about what is software evaluation, and software paradigms. So these things we have already discussed about what is software engineering, need of software engineering, career opportunities, and what are the different qualities of the software engineering, software versus programs. Then we have discussed about what is software. Okay. Software is the collection of programs or documentation and operating procedures. Then we have discussed about some software components like programs, documentation, operating procedures. Then we have discussed about software products, and in the last we have discussed about what is software crisis or software failures. Okay, so these all things we have discussed in our first lecture of software engineering lecture series. So these are some software failures which we have already discussed. Okay. So like Y2K problems, the Patriot missiles, okay, and some financial softwares. So today we will discuss first what is software characteristics. Okay, so software characteristics, this is the graph for or we can say the failure curve for the hardware. So software does not wear out, but when we talk about the failure curve for the hardware, so first it will go into the burn-in phase, then then it will continue in the useful life phase, and then then at the end it will wear out. So this is like the Barth type curve for the failure rate of the hardware. But in the case of software, it is not like that. Okay, so this curve is not like that, this type of Barth type curve. But in the case of software, this curve will be some in some different way. Okay, so burn-in phase will be the same, useful phase will be the same, but in the wear phase because software does not wear out, we are saying that does not wear out, it means this curve will be ideally this one. Okay. So what are the important points about the software does not wear out? Software becomes reliable over time instead of wearing out. It may be retired due to the environmental changes, new requirements, new expectations. And when hardware components wear out, it is replaced by a spare part. Okay, but there are no software spare parts. So hence software maintenance requires more complexity than the hardware maintenance. Now this is the failure curve for the software. So software is not manufactured. Software use the some previous components, so we can say reusability of the components. Software is flexible. So this is the software failure rate curve for the software. So this is the ideal case. Okay, this is the ideal case. But due to the some occurrences of the changes, this curve actually will be this type. Okay, so result of the side effects. Okay, so this is the actual curve and this is the idealized curve for the software failure rate. Now we will discuss some software applications. So there are some we can categorize the software applications in the various fields, so like software, system software, real-time software, embedded software, business software, personal computer software, artificial intelligence software, web-based software, engineering and scientific software. So these are the some categories where we can use the software, or we can say the various application areas of the software. So these are some some examples of every area. In the system software, we use the compilers, editors, devices. Like in real-time software, we use the monitor, control, and analyze real-world devices. In the embedded, we use the ROM, control various devices, functions. So in business software, we can use the employee management system, library management system. AI software, we can use the expert system, game playing softwares. And when we talk about the engineering and scientific software, then we can say the AutoCAD package and MATLAB. So these are some engineering and scientific software. So, and when we talk about web-based development software, then we can say the HTML, Java platform. So these are some various application areas of the softwares. Now, what is the software engineering process? So how we can define the software engineering process? So actually, first of all, what is the software engineering? So software engineering is an engineering discipline which is concerned with all aspects of the software production. Okay, so software engineering is an engineering discipline which is concerned with all aspects of the software production. So software engineers should adopt a systematic and organized approach and use appropriate tools and techniques depending on the some problems to be solved, the development constraints, and use the resources available. So if we talk about the bookish language or bookish definitions of the software engineering, then we, according to the first conference on software engineering, Fritz Bohr defined software engineering as the establishment and use of sound engineering principles in order to obtain economically developed software. So that is reliable and works efficiently on real machines. Like Fritz Bohr, Stephens also defined the same definition as a discipline whose aim is the production of quality software that is delivered on time, within budget, and satisfying its requirements. So both the definitions are very popular, acceptable to majority, and however, due to the increase in cost of maintaining software, objective is now shifting to produce the quality software. So it means we are not focusing on the development of the software, but we have to focus on the quality of the software. We have to take care about the quality of the software, like we have to take care about the maintainability, we have to take care about the reliability of the software, we have to take care about the user needs in the sense of changes of the changes requirements. Okay, so it is not only sufficient that we are only developing the software, but we have to maintain that software and we have to focus on the quality of the software. Now, what is the actual goal of the software engineering? Okay, or we can say what should be the goal of the software engineering? So goal of the software engineering not only to develop the product, but we must say that to improve the quality of the software product, to increase the productivity, and to give the job satisfaction to the software engineer. Okay, so these three goals are very, very important for as a software engineering perspective. So to improve the quality of software product, to increase the productivity, to give job satisfaction to the software engineer. So now there are some challenges in the software development process. So the problem of producing software to satisfy user needs derives the approaches used in the software engineering. So there are some 3 or 4 important factors that affect the software approaches selected to solve the problem. So these are scale, quality and productivity, consistency and repeatability, and changes. So these are main 4 challenges during the software development process. Now what is the scale? So scale, software engineering must deal with the problem of scale. So methods for solving the small problems do not scale up for the large problem. Means when we are developing a software, then it should be the scalable. It should be the scalable. Means if we are developing the software and on the small scale, then it should work for the large system. Okay, or it can be scalable, or it can be used, or it can be developed for the large system. Productivity. So an engineering project is driven by cost and schedule. So what is the cost? Actually in the software perspective, cost is mainly manpower cost. So hence it is measured in person months. So cost is generally measured in person months. So schedule is in months or weeks. So schedule is very important in business context. So productivity captures both cost and schedule. So if P is higher, cost is lower. Okay. If P is higher, cost is lower. Means if productivity is higher, cost is lower. If P is higher, time taken can be lesser. So approaches used by software engineers must deliver high productivity. Now quality, if we say about the quality, so if truly speaking, we cannot define quality in one line. Okay, we cannot define a particular definition of quality in one line, because it involves the many dimensions, many criteria. So we cannot define the quality in one line. So quality is the other major driving factors. Developing high quality software is the basic goal. Quality of software is harder to define. So that is why we are saying that software quality is not, it cannot be defined in a simple 1 line or 2 line definition. Okay. So approaches used should produce a high quality software. ISO standard has 6, there are some standards for the quality of the software, to control the quality of the software. So like that, an example is ISO standard. So ISO standard has 6 software quality attributes, and these are functionality, reliability, usability, efficiency, maintainability, and portability. Now another challenge is consistency and repeatability. Okay, so these are we are discussing the challenges. These challenges: scale, quality and productivity, consistency and repeatability, and changes. So we have discussed about scale, we have discussed productivity, we have discussed quality. So now what is the consistency and repeatability? So sometimes a group can deliver one good software system but not a second one. Okay, it may be the scenario, one team which is developing a particular type of software, but maybe this team will not be capable to develop the another type of software. Okay, so this is the scenario. So key software engineering challenge is how to ensure that success can be repeated. So how success can be repeated means, if today we are developing a successful software, then tomorrow we will repeat this. We will develop the successful software by the same software team. Okay, so software engineering wants methods that can consistently produce the high quality software with high productivity. So There are some framework or there are some quality control bodies like ISO standard, capability maturity models. So these are some control bodies, governing bodies who take care about the quality of the software systems. So this is about the consistency and repeatability. Now what change? So in today's world, change in business is very rapid. Okay, so it is therefore expected that software supporting businesses should respond to the changes in order to achieve the task. So it is mean to do. So rapid changes has a special impact on the software. So therefore one challenge for software engineering is to accommodate the change. Okay, so this is a very typical challenge, very challenging task to accommodate the changes, because suppose when we are developing a software. Okay, so first of all we will gather some requirement from the user, but user can change the requirements in between the development of the software or anywhere during the software development process. So software engineering process must deal with that changes or with the changes by the users. Okay, so therefore one challenge for software engineering is to accommodate the changes. Now what is the software engineering approach? So software engineering approach basically deals with these three things: quality and productivity, technology, people and process. So this is called the iron triangle. So quality and productivity achieved during a project depend upon three main forces, and these three main forces are technology, people and process. So these are the three main forces, and that is why we are saying that it is the iron triangle. Okay. So what is the software engineering methodology? So software engineering focus mostly on the processes for achieving the goals. Process must be systematic, and software engineering separates the process for developing software from the developed product. Okay, so premises are like process largely determine quality and productivity, and suitable processes are lead to high quality and product. Now we will discuss we will introduce about what is the software process. So what is the software process? Software process include those activities, methods, practices and transformations that are used to create and maintain the software product. Okay, so this is the or we can say in one line definition. If we use the one line definition, then we can say the software process is the way in which we produce the software. Software process is the way in which we produce the software. So like this software process is what takes us from the user needs to the software that satisfy the needs. So we can see in this diagram, in the left hand side, we can see that there are some user needs, and these user needs are input for the software development, and this software satisfy these user needs. Now software process, when we talk about the software process, then we will talk about the what is the software process specification. So process specification is generally a set of phases. Okay, so each phase perform a well defined task and generally produce an output. So intermediate outputs like the work product. At top level, typically few phases in a process. How to perform a particular phase. So these are some process specifications. And to better describe the process specification, there is a way ETVX specification. So in this ETVX specification, E for entry, E for entry, T for task, V for verification, and E for again exit criteria. So there are four approaches, four steps: entry criteria, task, verification, exit criteria. Entry criteria means what the conditions must be satisfied for initiating this phase. Task means what is to be done in this phase. Verification, the checks done on the output of this phase. Exit criteria, when can this phase can be considered done successfully. So a phase also produce information for the management. So this is all about the ETVX specification. Graphically, we can see the ETVX approach like this: input as a entry criteria, then process steps, and then this is control, V and V, verification and validation. This is verification, validation, and verification and validation. Okay. Then this is output exit criteria, and after verification and validation, some informations can be used as the management process. Okay. These are some characteristics of software process, like is any software suitable to use as a process, may be used by many projects, understandability, visibility, supportability, acceptability, reliability, robustness, maintainability, rapidly. So these are some characteristics of the software process. So in today's lecture, what we have discussed about software process, software methodology. We have discussed about productivity, scale. We have discussed about software engineering challenges, goal of the software engineering, what is software engineering process. So in detail, in the next lecture, we will discuss about what is the software engineering processes. So and we will discuss about the similarities and differences from the conventional engineering processes. So in the next lecture, we will discuss the similarity and differences from the conventional engineering processes.